it's a layer that really benefits from like many companies, many people contributing, because there's a long tail. There's like so many different types of agents.
Awesome. We're back here for the next episode of First Pass with Matei from Databricks to discuss Omnigent and how the evolution of harnesses and meta harnesses with respect to agents is evolving. Matei, thanks for being with us.
Thanks. Yeah, thanks for joining me.
So talk to us about Omnigent. Like, why did you build it? Well, first, what is it? Why did you build it? How did some of the internal work that you were doing lead you to building this? Just talk to us more about what Omnigent is.
Yeah, so Omnigent is what we call a meta harness. It's a layer that runs on top of existing agents. It can run over coding agents like Claude Code, Codex. It can also run over custom agents, and it gives you some common features across them, like collaboration or security, or the ability to swap between them or combine them. And it really came out of seeing what engineers were doing with coding agents here. All the really hardcore engineers had many agents running at once and many ways to orchestrate them. And we realized this is sort of a new layer that's going to emerge on top of these.
That's awesome. And what was the biggest problem managing all of the agents? Was it the security? Was it the governance? Was it kind of copying and pasting instructions here and guardrails here over there? Like, what was the kind of the biggest challenge you ran into internally?
Yeah, so I think with coding, a lot of engineers said, well, I can vibe code my own agent orchestrator. Why do I need anything? But the part where they all stopped short and said, okay, I don't want to vibe code, that tended to be collaboration and also security. So collaboration, right? You got a great setup for yourself, but when you want to hand off your work to someone else to review or whatever, they don't know how to use your thing. They have to start again. And to build a collaborative, server, you need someone to host it. It needs to be secure. You don't want to just have everyone build their own. And then there's also security policies, which again, you don't want to do that on your own and maybe get it wrong. So these are things that led to like, yeah, maybe we should have a centralized thing. We also have a centralized like MCP and skill registry in the company, and it's nice that you get that through this as well. But these are the big ones.
Yeah, I have to imagine as agents proliferate and everyone's building more of them, having the single place to manage the governance and the auditability and the control and the security and all of that will be increasingly important, especially for larger and larger enterprises.
Yeah, even for individual developers, like one of the simplest things this lets me do that like no existing coding agent does is I can tell it to launch a sub agent and set a budget on it. Launch an agent to read the logs and investigate this, but tell me if it needs to spend more than $20. And like those are usually when I had some surprise bill, it's because an agent did something stupid like trying to read millions of lines. And since Omnigent knows about cost and support, I can ask it to launch any type of agent. It can very easily do that, but none of the coding agents out there actually let you do that.
Well, one of the other big advantages of using a meta harness is composability, both across harnesses and across models. One of the, we talked about coding agents, but one of the other examples used in the blog post is how Harvey uses both open source models as well as frontier experts together to create the best experience for their users. Are there other patterns you're seeing for composability, and how is that evolving?
Mm-hmm. Yeah, totally. Yeah, we're seeing a lot of developers actually use some kind of orchestrator and sub-agent pattern. So, for example, if I have a bug or something, I'll ask, hey, can you launch Claude Code and Codex and GLM in parallel and have them look at this bug and see if any of them figures it out. Or can you ask, this agent to build a thing and this other one to review it? And this pattern is nice also because the agents, I think, are smarter when they get a narrower task. Like if you had one agent running for a long time, it would fill up its context window and get confused. But here you can launch these different ones that are just doing one thing. So I use this a lot for most things, even for non-coding things. Like if I'm trying to research something about the market or, like teach myself something or whatever, I'll often use this. And I end up with like 30, sub-agents in the sidebar that did different things.
The other big advantage that you talked about was collaboration and having humans collaborate and how they sort of conduct these agent swarms. How are you using Omnigent to collaborate with your coworkers at Databricks?
Yeah. It's huge. We're using it, like we use that extensively to develop it, and now like many engineers are using it. So one of my favorite features is you can have your agent write a plan as like a markdown file or HTML, and then you can invite people to leave comments on it or to edit it, exactly like Google Docs. Like they get the rich view, they can highlight, leave comments, edit, and then I can say, okay, agent, take all these comments and like go address them. Another cool thing is instead of code review, like imagine I spent like hours talking to my agent, it produced 10,000 lines of code, and then I plop it onto GitHub. What's the person reviewing going to do? They're going to immediately launch an agent and ask it what the heck is going on in the 10,000 lines. I can instead just share the session, and then they can take it over and see everything I did, like ask back about like, hey, why was happening at this stage, and continue chatting with an agent that has that context already. Yeah, these are some of the big ones.
Awesome. Why'd you choose to open source it?
Yeah, there's a couple of reasons. Like one is we felt this is a layer that's just gonna emerge, and it's a layer that really benefits from like many companies, many people contributing, because there's a long tail. There's like so many different types of agents you want to integrate with it. Since we launched it, we released with like 3 coding harnesses. Now it's like 20 that are supported. And there's so many LLM providers, so many things you want to connect it to, so many tools, so many different like policies you may want to write, like the security policies that understand different things. So if you make it open source, then you collaboratively build that, and everyone benefits. And we've done this before with other things. I think open source works great when you want to share basically development work and make sure it's integrated with a lot of stuff. So for example, with Apache Spark, like we didn't have to write a connector for MongoDB. We didn't have to make Spark run on Windows. Actually, I did that the first time, but then some other people maintained it, and I never had to write a CMD, batch script again, which I had to learn before LLMs. So there's so many things that you get from that. And we also have this MLOps project at Databricks called MLflow. So again, when MLOps used to be all proprietary mostly, we decided to make it an open source thing. So like all the ML libraries integrated with it, all the serving platforms and monitoring integrated, and we benefit from having all those. And then the other reason is, even though this is used a lot for coding agents now, we saw the exact same problems with custom agents. We have all these teams that ended up writing like a little YAML driven config framework to specify their custom agent. And then anytime they want to switch harness or switch model or whatever, it's a huge engineering pain for them. Anytime they want to implement sharing or social features or commenting, they do it from scratch. So we thought this is a great starting point for custom agents. Like in my experience, any custom agent is not going to be good until you have people using it for real work. And for it to do that, it needs to solve security, sharing, durability, UX, all these things. And this is a really good starting point for that.
Is there any... I feel like there's so much value to a meta harness, and everyone will initially look at kind of cost and control and security and governance and auditability and those types of functions. When I think about a classic harness, I can't remember who did the study, but there was some study that showed, hey, you could use the same model, but based on what harness you used, you could kind of drive a meaningful difference in performance. And the takeaway of the study was, hey, the harness can actually be a big driver of performance of the underlying model.
Yeah.
Is there a performance boost you can get from having a meta harness in the same way you can get a performance boost from an individual harness on an agent? Or is there less of a performance story around Omnigent?
Yeah, there can be in a couple of ways, and there's definitely a cost performance one. So for the cost performance one, actually, we're doing a lot with like routing on top of this. And in fact, just today, we put out a blog post on, we actually built an internal benchmark based on our engineers' tasks for coding agents. And then we ran all the leading agents and harnesses on them. And we found some really interesting things. Like, for example, Opus as a model performs the same using the Pi harness as with Claude Code, except it costs about 2x less. consistently across tests. It seems to be because pi just shows it, less input each time. So you could sort of save 2x and get the same thing. And then likewise, like, GLM does better with some harnesses than others. And then the other thing is with this meta harness, it's very easy to mix and match subagents. So in a lot of our production agents, for example, we have a subagent that searches for like relevant content or something, and that's a much smaller and cheaper model, or an open source model. And then perhaps for like formatting and reasoning the final answer, we have like a frontier model. The other way it helps is if you want to do like multi-agent debate or ensembling. So for things where like, for example, finding a bug, it's, when you find it, that's it. But before you do, you just need to try lots of ideas. And I found that launching different agents with different models like helps me find it faster. It's a good test. There are other things that you can't really parallelize that way, but that one is because like you just have to explore a bunch of hypotheses, keep generating them, and these models do have different biases from the beginning, so you're more likely to find it that way.
Well, what's the future of Omnigent? Where do you take it from here?
Yeah, it's still early on. We really hope that it becomes a good way to build custom agents too. So we'll be focusing a bunch of that. And some of the things we're working on are making it actually adding more built-in agents for different tasks. I'm actually working on an auto research agent. This is some of the research I've been doing also at UC Berkeley and at Databricks. Is like, how do you have AI, search for like how to solve a problem. So we're going to put in that to make that easy, and then working on making it really easy to write a custom agent in YAML and then serve it and have multiple UIs for it, or customize the UI, put in your own artifacts, your own things like that. And then the final one that's like very deep, I think, and difficult to do well is the security and cost management policy. So we're doing a lot with the routing and with having really good, security out of the box. And these are both like very dynamic. They change as the models and adversaries and so on change.
Awesome. Well, look, Matei, thanks for being with us today to discuss Omnigent. We're all quite excited to see how that product evolves, and maybe more interestingly and more importantly, just how Databricks evolves. I've always been quite impressed how Databricks started off as like the Spark company, around data processing. Then it was the Lakehouse and the Warehouse company. Then it was the AI company. Now it's the agent company as well as the application company. There's very few companies that have been able to reinvent themselves as many times as Databricks has. We love following the story. Think you're making a ton of progress, and thanks for joining us today.
No worries. Thanks.